And we're live again back at AHR. Now we're in the Sporlan booth, sitting here with beautiful, beautiful Las Vegas. We've been at the AHR. I can't even talk today. Over at the AHR for now the past 2 days, and place is huge. If anyone's ever not come here before, I would highly recommend that you guys come over here. Come over to the Sporlan booth. They have some of the new coin wrenches, so you guys can stop complaining about the not using the square anymore. Other than that, I guess I don't know. Let's talk about some CO2 stuff. We've seen some more CO2 stuff out and about. A lot of new CO2 heat pumps. I don't know. Let's talk about some CO2 troubleshooting, I guess.
Seen Amphicon had some pretty cool new stuff.
What do they have?
They had a new sensor for the Stratus that does like test gas. So it's 95% nitrogen and I think 5% helium.
Okay.
So it's a test gas. Like you can get it from pretty much any gas supplier. And it's pretty, I looked it up, it's a pretty common thing. So they use it a lot for, pipe testing, so that you can use this test gas as you're pressure testing with nitrogen and throw the sensor in, so you don't have to use refrigerant as a trace gas anymore. You could use it on the initial pressure test while it's holding. So you could pressurize the system, throw that test gas in there with it too, and then do your testing and go through and leak check while you're doing your pressure hold. So you could find your leaks while you're doing the pressure hold and not have to blow it all down and put refrigerant back in it.
So helium, is helium in there a gas though?
Not sure.
I'm kind of curious how that would actually work, because I mean the reason why we use nitrogen, right, is to, for that very reason. But like, is that trace gas going to actually
cause that much of a?
Yeah, and then
I guess it would depend. I mean, I'm sure they have some kind of table for it because it's a known thing. So, I mean, this is a pretty used thing. So, I mean, I thought that was pretty sweet though. The new setup.
No, we'll have to get them on to talk about it a little bit more. One of the things that we were going to talk about, I guess, I know we did a podcast before. We talked about this a little bit before about the 326 and how to replace that if God forbid you don't have another 326 because they don't make them anymore. Danfoss is now making a 326 replacement that has communication capabilities that can talk to a lot of different protocols. So that's really cool. I'm actually going to try to get my hands on that so we can do a podcast on that. Any other things that you saw that were CO2 before we start getting into some of the troubleshooting stuff?
Not really. I mean, I only got to walk around a little bit. So, I mean, Bitzer had that 8-cylinder CO2 compressor up there.
140 horsepower.
The thing was massive.
I think they said they have, maybe one client that they actually have that compressor in. So
it was huge. It was an 8-cylinder, massive Bitzer compressor.
And it's all digital compressor as well, if I'm not mistaken, right?
Every cylinder could unload. So, I mean, that thing was pretty cool. So, I mean, it was massively heavy. So, what did you want to talk about? CO2?
We were going to talk about certain things like when you're doing startup, right? What is some of the biggest things that you see out there?
Oh, by far, it's the cases miswired.
Okay.
My big thing is these Wago terminal blocks that everybody's using with the jumpers. It's been a nightmare. So specifically one manufacturer where they're not stripping out the wires long enough for the Wago terminal blocks, and they're going in there and they're grabbing the outside insulation with the Wago.
Is that the one with the actual arm to clip it in, or just the jam in? It's the
jam it. It's the push in button Wagos.
Okay.
So they're not catching everything, and they're getting the insulation, and it's you're
not getting good contact on the wire.
And it's happening on neutrals, which a lot of the time. So it's even harder to troubleshoot, because I was at a startup in Dallas, and they were using, the guy was going to ground, and he had 120. Well, he had an open neutral.
That's one of the reasons why I actually don't like how Trane does their rooftop units.
I hate it.
Because you can measure across a contactor and you'll have 24 volts and it'll look fine, and you're but it won't pull in. And it's because they basically use the neutral to basically open and break the circuit on their control side.
Yeah, I mean, the electrician was checking it, and he had the open neutral. but it was shoved in the Wago in a weird spot. So like those Wagos, like honestly, I'm not a big fan of them unless you're using ferrules with them because they just seem like it's just nonstop problems.
Yeah.
I would much rather have a screw terminal any day, especially in a case where you're shoving things underneath. But that's been a big thing. And then the jumper wires on those Wago terminals, you got to really watch where they're going and make sure that that's set up. And then we've had a rash of pulse valves wired wrong and wired hot. So
How does that happen?
well, they instead of wiring it to the the way on the Wago terminal block, they miss one jumper over, and then it's wired to straight 120 volts.
Oh, where it's like it's supposed to be the 120 where it goes to break it, but then the out of where it's supposed to go the valve, they're putting it right on the hot.
Which is why I'm not a big fan of that. Like I'd rather just go right to the Dixel controller. There's no point in running it to a terminal block.
Why? Yeah, I don't know. There's some manufacturers that so like Husband, we've seen it more and more, or all the time, where like all their schematics. Typically, it doesn't matter if the Peckerhead has the high pressure, low pressure, whatever. All those wires go back to a terminal strip. I guess
that's how they should.
And I agree, but it's the ease of troubleshooting for that.
Well, yeah, I agree, but like underneath the case, it's stupid because it goes like 3 inches of wire to a terminal block, and then you somehow wire it wrong.
So, the push ones that you're referring to, these are the ones that have the little orange push button that like the Hill Phoenix Advancer racks, how they do their controls.
It's the same exact terminal block.
Okay, all right.
For the cases.
That's what I thought you were.
Why did you just out them?
I'm not. I'm just saying like those are because those are the only manufacturer that I know of that is essentially using those ones for their control stuff.
No, Husband's using them too.
All right. Well, I didn't know that. Now I do.
Yeah.
So I'm just saying those are the ones that I had experience on.
So the other wet style Wago terminal block where you got to insert a screwdriver in.
Yeah.
To get the wire out. There's a special tool for that.
Okay.
So Wago makes Wahala, however you say it, makes a special screwdriver for the like $8 on Amazon. It's got a curve in it and a certain size slot. You basically just stick it in there and just barely pry up on it, and it opens up the jaws for those things 10 times easier than a screwdriver will.
Oh, okay. Like I said, if I had 2 screens and a proper mouse, I'd probably pull it up. All right, but I'll make sure I do that next time.
You have 2 screens.
I know, but
I have 3 screens.
Fine.
But no, you don't have to. But yeah, that's one thing that does make those terminal blocks easier.
What's the screwdriver called again?
I don't know, Wahala. It's a Wago terminal block screwdriver.
There you go.
But if they would start using ferrules, I mean, a lot of that would go away, and you wouldn't have those problems.
I know you're a fan of those, but like I've heard mixed bags where they're like, oh, I don't like them because they're screwing them up.
How do you screw up ferrules?
I don't know. I'm not there, but I'm just people have been complaining where they're not making good connection, like specifically for like sensor wires and that.
They should be if you do them right.
I agree, but is that the one?
Yeah. So yeah, they there's different versions of it, but that is a lifesaver when you're doing like a lot of the terminal blocks.
So that's the one that Kevin's talking about. So that's what are they calling that? The Wago operating tool, 100 millimeter tool, large one-way blade. So that essentially that's what's pressing it down instead of using a control screwdriver to do that. Yeah.
Well, you don't want to with a control screwdriver. You get to like jam in and pull down. You don't want to do that. You want to insert and just pull up.
Gotcha.
So that's why you end up bending your screwdrivers.
Gotcha. All right, that makes sense.
Yeah, no, that's been the majority of the issues, and then I mean most of it's been case wiring, and we spend more time fixing case wiring and sensor wiring than you do anything.
No, we talked about backwards cases, but you said the fitters shouldn't be, or the case setters are setting the cases. You don't think they should be at least looking at the liquid line and suction line?
Case setters are carpenters. Carpenters set cases. Carpenters.
I don't know how they do it up in the union. So, and tell me. So which one? Because which ones are setting the cases and putting them together?
Carpenters.
Okay.
Pipe fitters, pipe cases.
Okay, so how comes the carpenters can't check those?
Because they're carpenters. They don't. That's pipe.
But
fitters.
that's like the best time to freaking look at that stuff, right?
The pipe fitters should look at it.
But at that point, the back wall's already reinstalled. Yes.
No.
Oh, it's not.
They don't have the back wall installed till generally they're piping the cases.
Okay. But in the job that you were just on, you said there was a couple different cases that were backwards. Yeah.
No,
No.
no, not the job I was on. I mean, honestly, top fed cases are nothing but a nightmare. I mean, they're easy, they're more of a hassle to pipe, and if they were bottom fed, it would eliminate 90% of the issues. Not to mention you don't have to insulate all that.
Yeah, I don't know. So you're thinking what? You just one feet in the bottom, and then case, put all the case piping in the bottom.
Yeah,
Okay.
like we do for everything else. I mean, the more piping up top, the more you got to insulate. The more piping is going to be up there. The more you use lay in the bottom of the case.
Yeah, no, I get that, and like I don't know. So still finding a lot of case temperature sensors swapped.
Yeah,
Yeah.
I know that's a never-ending thing, and it's walk-in sensors or walk-in coils. Depending on the electrician did them. If there's multiple coils and in one panel, it's nonstop with it. So
I don't know why. Like I've seen a brash of different ones lately where the temperature sensor is actually temperature sensor for defrost termination is right by the heater at the very top heater. I don't know if that's a OEM like a manufacturer, like that's how they're.
yeah, I've been moving those.
Well, yeah, because it ends up causing the termination to end prematurely.
Oh, the other thing is with that, like I'm trying to push for our branch to start pulling different color wire when they let us. So like yellow for defrost term or orange for defrost termination, green for temp sensor, blue for suction temp, and then obviously I don't really care about the suction pressure because it's going to be an 18 gauge
Yeah.
for wire, so like that. And then a valve, different color for the valve. I mean, I would much rather see it done in that, so that way, I mean, it's harder for these guys to screw it up. So the blue wire goes to the blue sensor, the orange wire goes to the orange sensor.
Well, if you Danfoss, then the red sensor's red, and then you have to get red wire.
You switch it up, make the blue sensor the suction one.
Well, that just gets confusing. Then you can't have everything uniform.
Yeah, I mean, I think that would be much easier for these guys to not screw it up on remote polls, where you have a bunch of stuff going in, so it would just be easier in general.
Okay. Well, listen, with the conversation we had this morning with one of the people we know, we were talking about vessels and how sometimes they can be really dirty. You were telling me something this morning that you typically do to make sure that doesn't happen. You want to go over that?
So when I blow the racks down to do put the filters in and start pulling the vacuum, generally what I'll do is I will open the suction and liquid core lids, and I will start. I will valve them off first, and I'll blow the rack down nitrogen. I will blow everything backwards, so that way we could blow everything out from inside the rack and gas cooler back into the rack and then out the liquid cores and suction cores. So that way you're just not going on a 1/4 inch port. So like you can getting any race soot, any slag out of the tanks that you could out without trying to get it trapped somewhere. It's not a ton, but like every little bit counts. It doesn't end up in an expansion valve.
So talking with one of those manufacturers this morning, like I didn't realize that when they do the hydrostatic test, that they basically pressurize those things with water, like the vessels, like whether it be an oil reservoir, whether it be a flash tank, whether it be a receiver, they actually do a legitimate hydro test on it where they're pumping it up with water and then doing X pressure. And I didn't realize, like depending on how dirty or clean that water is that they're using for the hydrostatic test, I mean, you could essentially end up with a whole bunch of crap within the system even before it's piped in.
Yeah, no, he was going over how they sandblast the inside of the vessels and then go through after the welding, they sandblast and clean it all out. And then they have to hydrostatic test it. But some facilities don't hydrostatic, or they reuse the hydrostatic water that they were using the pressure test. So, like, you end up putting brackish, nasty water back in there and causing more issues. So,
yeah, because you were saying you've seen anything from like welding smut from the stick welding, right? You sound like there was sand in there as well, like maybe some of the castings from some of the compressors.
I mean, yeah, I mean there was sand-like material. I mean,
Gotcha.
it could be anything. I mean, any of that fine sand-like material it's going to cause problems. So it's like you want to get all that out, and the more you get everything out and clean, the better. But blowing it out seems to help a little bit with keeping stuff like that from happening.
Yeah.
And then the other big thing I just see is this oversized equipment. Like we've been fighting this for forever. These oversized compressors, it's killing us.
Where you have to make sure you have every bit of load up there, so it doesn't end up short cycling. It might work fine in the summertime, where it's not grossly oversized, but in the wintertime, you're just, it's too much, and they could potentially cause, a lot of pump downs. We've seen it on graphs all the time where the suction pressure ends up, being down to 250, 300, 300 pounds when it's supposed to be right at 400 for the medium temp.
So we've been doing a lot of rolling remodels and like doing these and starting up like 1-2 cases, and they got to start the rack before, and I got to get this running for these guys the day before. So what I've been doing is I've been setting a minimum opening percentage in the iPro or the Danfoss controller and just making this thing run in a loop basically. So it'll keep like say 15-20%. It'll keep the high pressure valve open 20%, which is going to inject more load into the flash tank, which is going to then make the medium temp have more load. So it's like a perpetual motion machine in the beginning. You get it. Once you get it running, it kicks up and loads up enough itself, just running gas back and forth. It's super not efficient, but like it'll keep you running long enough to get some load on there and start switching over cases, add more load, and dealing with it then. So make sure you take out the minimum HPV percentage afterwards. But I've also had pretty good luck with it. This cold snap we had, I got 2 racks right now that have a minimum of like 22% for the HPV, and that's a sweet spot enough where it loads up enough in the cold to keep everything running and keep a compressor on and keep everything from going into shutdown mode every time a pump shuts off.
Don't be surprised if you see the subcooling value when it's that cold outside.
Oh, it's all over the place. You don't even care about it.
Yeah, you're just because you're trying to just keep the rack running at that point.
It's like what's worse, you got some subcooling all over the place, or you got a rack that it's short cycling and gonna eat a contactor, or it's constantly throwing the cases into shutdown mode. I mean, I'd much rather have a rack that's running like that. So
yeah. One of the things that we've all seen as well is that remember that all the mass flow of this whole system goes through the high pressure valve. If that system is dirty, regardless if it's coming from the rack, regardless if it's coming from the actual cases where someone what would they say attempted to purge nitrogen, you're still going to have all that the stuff is going to fill up in the filter screen. Typically, when you see that, you'll see that the high pressure valve will have, like, if it's running subcritical, you have an exuberant amount of subcooling, more so than what it should be. And you'll see the valve percentage like potentially go up to 80, 90, 100%. One of the telltale things is, like, if you have a running system where the high pressure valve screen is not blocked and you run that high pressure valve all the way up to 100%, you're going to overtake your flash tank. I don't even think you'll have enough capacity to bring everything down. Would you agree, Kev?
well, yeah, I mean, you're just not. It's just gonna block up and start causing high head pressure trips eventually.
So when you're checking it, don't be surprised if you have, like I said, if you suspect you have a screen blockage and you have extremely high subcooling. Essentially, the valve's going to want to open up to potentially 100%. Now, typically when that happens is you'll start booting up a whole bunch of compressors. At that point, if that screen is blocked before the high pressure valve, you'll also even see the BGV basically not go. It won't open up nearly as much as what it would be. But yeah, those are some telltale signs that you can actually see. Sometimes I've had guys just for a test. I'm not recommending that you leave this in there, but a lot of different systems will have a tap before and after the high pressure valve. So just to test your theory that you think that it's blocked, you can essentially put a hose from end to end and bypass the high pressure valve just for a test, just to have
This seems very much in the territory that you would silence me.
No, well, no, that's why I keep prefacing that it's just for a test. It's not, don't leave it on there for 2 days because it's working. You know what I mean? You're just doing this for a test to verify that you actually have some sort of blockage.
Okay, another one we've been seeing a lot is the flash gas bypass valves failing. I was just dealing with one yesterday that the motor wouldn't close all the way. It wouldn't close all the way. Well, they took it off and it walked itself. It was a Danfoss valve. It walked off the stem. So with those ETS valves and some of the CCM valves, they will walk off the stem sometimes. Now, I've had it happen to me multiple times.
CCM, not CCMT, right?
Yes.
Okay.
So we've had a couple of those walk off. So what you do is you generally take them. You can unscrew the head. Well, you got to get the shaft back on the actual plunger. So what you end up doing is unscrewing it, and don't freak out because the plunger is going to come out or be inside still. So the plunger's held in with a different screwing apparatus. So what you do with that is you could take the new motor, spin it on there. I think it's like 3.5 times. You got to read the manual and figure out which, because it's a different amount of turns, I believe, for different valves. So you screw it back in, like 3 turns, push the plunger down, and then screw the valve back in, and then you could zero it shut, not open, shut, so that way it doesn't walk off. And then the other thing, if you see like a bunch of brown goop in there, more than likely the motor's going to be trashed. Every one of them I've seen with the brown goop, like it's like some moisture induced, like wax type stuff.
Oh, okay.
When you see it in there, 9 times out of 10 the motor's shot. It's usually burned out by then, and
It's weird because
so it's dragging.
that's weird because the valve basically is not a as the valve motor is it's not in contact with the actual CO2 itself.
No, it's not from the valve motor. It's just a lot of the vapors going through there. So it's just picking up contaminants.
Okay.
And then same thing. If you guys got to throw this on an SMA, you got to switch the black and white out on the SMA.
Yeah, I'm trying to find where the actual IOM. Does it actually say in the IOM about the rebuild, or is that a separate
Yeah.
document?
No, I think it has in there.
Installation. Here you go. Why do they do that in like 20 different languages?
I don't know, but like this is a common thing with these things coming unscrewed.
Okay, so we got.
You downloaded the wrong manual.
I didn't. Electrical connections. English, right there. Two full phase stop. That's not the one that.
Yeah, there it is. So it's 2 to 3 times.
No.
So you screw it in 2 to 3 times.
Damn it. Hold on. Remove. Stage. What am I doing? I don't even know what I'm doing anymore. Is it time for bed yet? I'm exhausted. Stop screen. Present. Share screen. Tires. There we go. Share that screen. So there's your instructions for what you're talking about. So it has to be tightened down to 41 millimeter. No, that's the wrench. Sorry.
Yeah. But no, it's 2 to 3. This is the most important thing. It's 2 to 3 turns. Now, I have gotten pretty lucky with the O-rings on these and on the flash gas bypass valves without taking them apart, without needing one. I mean, I would much rather have one, but taking them apart without one, they'll still usually seal up because it's gas and not liquid.
Oh, so you're saying like these are the ones that you're talking about where they're on the on the BGV.
Yep.
Not the high pressure valve. Yeah.
So an HPV would be a T. So the other thing I want to show you. So see the stem. You got the stem screwing into that hexagon thing.
Yes, sir.
Okay. When you push that all the way down, so inside of there is a internal retaining screwed in thing. So the best way to get that out is with a 3/8 rod coupling for
rod coupling.
Rod coupling. Like 3/8 threaded rod.
Threaded rod. Okay.
So
okay.
you get a 3/8 threaded rod coupling, and if you touch up the edges a little bit with a grinder, it fits in pretty snug. And then you can put a crescent wrench or a wrench on it and screw it out that way.
Oh, I get what you're saying.
Because it allows the stem in the middle to go through where the 3/8 rod coupling is.
Gotcha. So so they have the part number for this. No, we don't remember. We downloaded the one that was the specific CCM. I think it was for the 10 or the 40. But you'll have to download each manual to actually get the actual part number that you need for that particular valve.
Yeah. No, and it's the same with the ETSs. We've had a bunch of problems with them coming unscrewed. I mean, eventually the valve takes a dump, but I mean, it usually gets you back running and back going. But that's been a huge one. And then most of the time I've seen them where they unscrewed was they were wired wrong on startup and they were shifting back and forth to not be. They were supposed to be opening and they were closing, and vice versa.
Gotcha. Anything else you want to talk about, Kev, for today?
I think that's it.
All right, guys. Well, hey, man, thanks for listening. If you guys are down in Vegas, down at the AHR Expo at 2026, come down and hang out with us, and we'll be here until about 5 o'clock. Come on and hang out. Talk to you guys later. Bye.